Hello, my dear friends. You know, the greatest show of the world is going on right now. The World Cup, FIFA World Cup football 2026. Who will win the World Cup? And an ICC event is going on right now in England. Uh, India already finished their journey. Now, who will win the World Cup? Mathematically, if we want to know these things, that the chances of winning, chances of lose, the prediction is this. So it deals with one famous chapter, that is probability. This topic you ICC student have been learning since class 6 onwards. So let's start the new chapter, probability. It's quite interesting chapter. I assure you, this is one of the easiest chapter. What is here means in class 10, it is very easy if we understand step by step. I will teach you step by step. Please be with me. I told you, if you understand this chart, no? This chart one by one, then probability will be like a water. So first come here. What is written here? Random experiment. First is random experiment, then is sample space, then is events, then different kinds of events. We will understand step by step. First is random experiment. Before jumping to random experiment, we have to understand this trial and outcome. What is trial? This is a coin. If I toss it once, this is called one trial. This is called trial. If you roll a dice, this is called trial. If you do it twice, to two trials. Now random experiment come here. This is the basic thing. If all the things are clear, I am assuring you everything, every sum of the probability you can solve. Random experiment. What is random experiment? Random experiment, first try to understand by an example. This is a coin, so I toss it. This is an example of a random experiment. If I roll a dice, this is also an example of a random experiment. Why is it called random experiment? Look at here. If I toss it, now I know either head or tail will come. Either head will come or tail will come. So I know possible results, but I don't know in this particular trial what will exactly come. Means this time head came, it may tail also come. So we know the possible results, but what will exactly happen in this particular trial, that is not known to us. So these kind of experiments are called random experiment. So random experiment, what is the definition? The random experiment is an experiment whose possible outcomes, what are the outcomes? Outcome are, is it, if I toss it, head or tail will come, so they are the outcome. Okay, so head and tail, they are outcome. So random experiment is such kind of experiment whose possible results or outcomes are known to us, but what will come exactly in a particular trial, that is unknown. This kind of experiments are called random experiment. I hope it's clear what is random experiment. And Example is tossing a coin, rolling a die. Okay, they are the example of random experiment. Now come to the next step, that is called sample space. What is sample space? Sample space definition is the set of possible set of possible outcomes of a random experiment is called the sample space. So set of possible outcomes. If I toss a coin, what are the possible outcomes? Head, yeah, tail. So they are set. We write. You have to have the concept of set here. Okay, little bit concept of set here. So we denote this. We write the set in set builder in roster form or set builder form also in this second bracket, and we denote the sample space by the capital letter S. So this is for tossing a coin. If I rolling a dice, what are the possible outcomes? 1, 2, 3, 4, 5, 6. So their set is the sample space for that particular random experiment. What is the random experiment in this case? Rolling a die or dice. Okay. Now I think it's clear. First random experiment, then sample space. Then come to the events. What is events? Events is subset of sample space. Okay, subset of sample space is known as events. Subset, head or tail, head comma tail. This is a set. So each subsets are, what are the subsets? Singleton H, singleton T, HT, and phi. They are set. This is power set. Power set or set of subsets of a set is called power set. So each element of the power set is an event. Is a head. Getting head is an event. Getting tail is an event. Getting head or tail is an event. And getting none of them, that is also an event. We'll discuss, they are here. Okay, we'll discuss one by one the events, impossible events, mutually exclusive events, favorable number of events, favorable events, sure event, exhaustive event, and complement of an event. Let's start. First, impossible event. Okay, impossible event. Impossible event. If I, it's a very good example is there. If you roll a dice, can you get 8? No. You will get either 1 or 2 or 3 or 4 or 5 or 6. You will not get 8. So, getting 8 is an impossible event. An impossible event is denoted by phi. Impossible event is denoted by phi. Okay, is denoted by phi. Okay, so it's an impossible event. You understood the example. Okay, getting 8. Okay, Okay, this is an example of impossible event. I hope it's clear. What is impossible event? Now come to mutually exclusive event. To understand mutually exclusive event, you have to have some knowledge about the set. What are disjoint set? Disjoint sets. Disjoint sets means, look at this set and this set. They don't have set A and set B, they don't have any common element. So they are disjoint sets. They are disjoint sets. And since they are disjoint sets, in probability, they will define these mutually exclusive events. Let us take an example. If I roll a dice, what are the possible outcomes? The ace is 1, 2, 3, 4, 5, 6. Now I am making two events. One event is getting even numbers, and another is getting odd numbers. Two events are there. So let the set A defines this getting even numbers. Getting even numbers, which are even numbers here? 2, 4, 6. So 2, 4, 6 are here. And getting odd numbers. Which are odd number? 1, 3, 5. 1, 3, 5. So is there any common element? No. So this set is 2, 4, 6, and this is 1, 3, 5. So these two sets has no common element. Since they don't have common element, so they form the disjoint sets. They are mutually, in probability, they are mutually exclusive events. They form the mutually exclusive events. And in set, we studied that if two sets are disjoints, if two sets are disjoints, A intersection B equals to 5. So here also this will be. So we will come to the probability of them later. But you just understand which are mutually exclusive events. Okay, they which don't have a common element. I hope it's clear to all of you. Next, I am coming at last this one, favorable number of favorable events. Next we will discuss this one, sure event or certain event. What is sure event and certain event? If I ask you, Asha, I am rolling a dice, okay, what will happen? One naughty and funny student of my class, he told, sir, from 1 to 6, any one of them I will get. It's correct. It's correct. So that is certain event. That will surely happen. That will surely happen. Okay, that is called certain event. That is called certain event. Now come to here. Complement of an event. Here also same concept, set. Complement of an event. Come to the set first. Complementary set. This is a set A. Its complement of this set A is A dash. Where is A dash? Except A. Except A. This which are here, they are they form the complement of a set. Okay, so if let 1, 2, 3 are here and 5, 6, 7 are here. So what is set A? 1, 2, 3. What is A dash? Which are not in A. Not in A. That means 4, 5, and 6. I hope it's clear. 4, 5, and 6, which are not in A. They form the complement of the set A. Complementary set. Same thing here. If we understood the what is the complement of a set, so here we will understand what is complement of an event. If I toss a coin, getting head, its complement event is not getting head. Getting head, its complement event is, if A is this event, so A complement is, or A bar, A prime, not getting head. Not getting head. So getting head is an event. Its complement is not getting head. Okay. Don't say that tail. Yes, we know that it's tail. But complement of an event is not getting head. Most interesting thing is, if you getting head, this is an event, and its complement means tail. So if you make union of them, you will get what? You will get union this one. We will get head comma tail. That means the sample space. Okay. So they will make their union is made the sample space. So they are exhaustive events. Exhaustive events means the events which their union make the sample space. That is called exhaustive. They are exhaustive events. Like these two example you take, getting even numbers and getting odd numbers. Okay, if I make their union, getting even numbers, 2, 4, 6, union getting odd numbers, 1, 3, 5. So if I make their union, I will get 1, 2, 3, 4, 5, 6. The sample space. So this is called, they are exhaustive events, which their union, since is the sample space, so they are called exhaustive events, and they are complement of any complement events each other, because they are for it's getting head, getting even numbers, its complement is getting odd numbers. Okay, complement is getting odd numbers. So I hope it's clear what is complement of an event and which is exhaustive event. You may have some doubt that complement of an event, they are actually mutually exclusive events. But only mutually exclusive events form the exhaustive events? No. I hope complement of an event is clear to all of you. The last but not the least, this favorable events we will discuss is very important. Favorable event. So let us take an example, funny example. What do we do? As a favorable events, we all know how to play Ludo.
Let you are here. This is your position. This is your position. Your opponents are here.
Your opponents are here. You are playing Ludo. You are here. Your opponents are here. So these are the tokens. These are the opponent's tokens, and this is your token, or we call it Guti. So these three are your opponent's tokens, and this is your token. Now, what will be your prey when you will roll the die? So you are praying, God, give me either 2 or 4 or 6. So this is your wish. 2, 4 or 6. So if it happens, then the incident is in favor of you. So that is your favorable event. At the same time, that means what is your wish? At the same time, your opponent is saying, no, God should not give him 2, 4, 6. You give him either 1 or 3 or 5. So this is your opponent's wish. Okay, this is your opponent's wish. So what will happen? We don't know. But this is your wish. So they form this set is your favorable event. Means what is your wish? Try to understand clearly. If you consider your friend who is saying, I want 1, 3 or 5, that means that is his wish. So his favorable events are 1, 3, 5. There is in a cricket match, Subman and late Pat Cummins, they will be playing against each other. Then Suman tossed the coin. Pat Cummins told head, call head. So head is his favorable event. What is his wish? And at the same time, what is the favorable event of Suman? That is tail. That is tail. I hope it's clear. Favorable events. Because the definition of probability based on these favorable events. Okay. So I hope it's clear what is favorable event. Favorable means what is your wish. Okay. Those events are called favorable events. Let's jump to the definition of probability. Classical definition of probability. Classical definition of probability is probability of an event is denoted by P of A. A is the event. A is the event. P stands for probability. Probability of the event A is equal to the number of favorable events by total number of events. Okay. Number of favorable events by total number of events. By an example, let's understand. If I toss a coin, what is the sample space? Head, comma, tail. That is the sample space. Sample space is important. That was the random experiment tossing a coin. Now your event is find the probability of getting head. Getting head equal to. Now what is the definition? Number of favorable events. What is your sample space? This is the sample space. What is your wish? Getting head. How many times head is there? One time. So number of favorable events, that means 1 by total number of events in the sample space. in the sample space. Total how many events are there? 1, 2. So this is the probability. This is the probability. Let us take another example. If I roll a dice, then what is the sample space? If you are able to write the sample space, everything is clear. Then what is the probability of getting a prime number? What is the probability of getting a prime number? First, look at the sample space. Here, which are prime numbers? 2, 3, and 5. So this is your favorable events. These are favorable events. This is your set of favorable events. So how many are they? 3. In the sample space, how many events are there total? How many total number of events? 1, 2, 3, 4, 5, 6. So 3 by 6. You can make it in the list form. I hope it's clear what is probability. We'll solve sums, okay, and we'll discuss elaborately